Thank you all for joining our videocast this afternoon. Again, Bob Bylone with the Recycling Market Center. Many of you joining the call know me. We also have Archie Filshill, President and CEO, owner, inventor of AeroAggregates North America, who will be talking with this afternoon. So in any event, again, good afternoon to everyone. This is our the Recycling Market Center's Insights into Circularity series. We have intermittently hosted these types of discussions where we have an opportunity to get a little personal, be a little professional with the owner or administrator executive of a recycled content product or recycled content manufacturing operation. And in popular news, and as was featured this year at the Professional Recyclers of Pennsylvania's conference in July, we have again Archie Filshill with AeroAggregates, located near Philadelphia, Pennsylvania. So welcome, Archie. Appreciate you being with us this afternoon.
Thanks, Bob. Yeah, thanks for having me on.
Well, of course, AeroAggregates has been in popular news in recent months, with a significant repair work that had been done in the northern corridor of I-95 near Philadelphia. And we'll go into that perhaps in a little bit. But, many of the people on the call today are drawn to the call because of one of your manufacturing ingredients, which, of course, is color mixed glass. And even some of the glass that the whole entire rest of the world doesn't want, right? So consequently, why don't you just give us a little bit of an overview of just a real quick comment on what AeroAggregates is, but even more so who Archie Filshill is and what brought you to this concept, what brought you to this idea, both personally and professionally.
Sure. So my background, Bob, I'm a geotechnical engineer, and I've been fortunate to be on a couple sides of the table. Right now, as a manufacturer, I spent about 15 years as a design build contractor, working all types of geotechnical projects. And during the construction career, we came into a lot of projects where we see the use of lightweight fill. And lightweight fill is used a lot behind bridge abutments to take loads off the abutments, or to take weight off of soft compressible soil so the roadway or the structure doesn't settle. And in the States, the traditional ultra lightweight material was polystyrene, or what they call geofoam, big blocks of polystyrene. So although it's been used quite a bit, we found that a lot of state DOTs were very hesitant because if you have a gasoline or diesel spill, it'll melt the styrofoam. And so you had to protect it in a fuel resistant membrane. And the more we were looking at that, we saw some of the issues with that and kind of wider acceptance. And part of my contracting group, we had an office in the UK and one in Turkey. And it was back with the team at a meeting talking about ways to manage ultra lightweight fills and all the concerns with styrofoam is where I got introduced to foam glass. And it's a material that's been used in Europe for 40 years now. So spent about 4 years researching it, doing all the ASTM testing, AASHTO, federal highway type requirements that they'd want to see. And then once we did that work, realized, okay, this is time to start. And we started the company in 2015 with production starting in 2017 in Eddystone, PA, right next to the Philadelphia airport.
Well, just to take a real quick go back card, because I know we've got other technical and engineering types on the videocast attending, but then we also have a lot of lay folks too. And I know that, and this may sound really trivial, but when I talk about fill and I talk about soil, I've got a hole in my yard, I fill it up with something, that's pretty much it. You use the term ultra lightweight fill or lightweight fill. In other words, it's not just about filling the hole in the sidewalk or in the yard. There's different types of fill for different situations. And if I heard you correctly, based on the what's under the surface, you can only put so much weight on top of it. And that's where your product comes in handy, because it can provide the strength of what you want to hold above the surface without adding all the extra weight of what you fill the area with, right? I mean, that's kind of what.
Correct. Correct. So what we see is if you look at traditional fill, which is soils and aggregates, they're up around 100 to 120 pounds per cubic foot. Lightweight aggregates are in the 50 to 65 pounds per cubic foot. And foam glass qualifies as ultra lightweight because we're down in the 15 to 20 pounds per cubic foot. So 85% lighter than traditional aggregate. And you're correct, where we see it mostly used are where you're building a highway embankment or a bridge approach, where you're bringing up 10, 20, even 30 feet of fill. That much weight would cause a lot of settlement. Or in some cases, there's underground utilities that weren't designed to hold that much weight. So ultra lightweight is a way a designer can increase the height of fills without putting extra surcharge on those utilities or those compressible soils. And I think, Bob, my favorite example that most people know is the bridge bump. You drive towards a bridge, you bounce on and you bounce off. That's because the bridge is on a deep foundation, but the soil embankment isn't. So that heavyweight fill will cause settlement over time, which causes that bump. If you use lightweight, you can reduce or eliminate that settlement for a smoother transition.
Understood. So next time I have the bump, I'll think AeroAggregates.
That's right.
Okay. Well,
Actually, don't think AeroAggregates.
you're
We
right,
have the
right,
bump,
right,
right?
right. Just the opposite.
All right.
Well, now you're using color mixed glass as your main ingredient here. And was that kind of a side benefit, or did you realize that early on? And I guess the color doesn't really matter. Strength wise, it's this, and what you make, it's the same result.
Yeah, it's one of the real kind of unique one of the unique manufacturing benefits of the material is that we tell a lot of people the glass that we use is definitely the glass that nobody else would want. We can handle smaller size, mixed color, where some of the container people and fiberglass recyclers, they need larger pieces that can be color sorted for their process. Where with foam glass, mixed color, smaller particles, larger particles really have no effect on the manufacturing process, which I think really separates us from a lot of other people trying to recycle glass that they need very specific colors and making sure there's no ceramics or porcelain mixed in with that glass as well.
So other than this project that some of us have heard about along Route 95, what are some of the other meaningful projects where your material has been used that you can, give us further examples of an ultra lightweight aggregate?
Sure, and maybe a best way to do I could start up top. We're doing a huge project in Maine right now where the Maine DOT is building a bypass road around Bangor, Maine on basically a very thick layer of clay. So they're using the foam glass about 100,000 yards to prevent the settlement. At Logan Airport in Boston, the ramps between all the terminals are about 20-foot high behind walls. All that fill is foam glass. Philadelphia International Airport was our biggest completed project to date, where they had to build an apron. And Philadelphia Airport's right on the Delaware River, a lot of old fill, soft compressible soils. So instead of using piles to support the apron, they excavated the heavyweight material, brought in foam glass, and poured the apron on top of it. So we're parked there. And this continues right down the coastline. North Carolina DOT building ramps over existing utilities. We're working on the Florida Turnpike right now, but we've also done DOT work in northern Minnesota. We just finished a project for Arizona DOT north of Phoenix and get ready to start some work with Washington DOT outside of Seattle. So benefit of being ultra lightweight, it ships a lot better than traditional aggregate also.
Well, and again, I know I stressed on this early on, but it really is the color and also size, the mix of glass that others don't want. Because my understanding is that, like at your Pennsylvania facility, you take in both glass from Pennsylvania and New Jersey, perhaps other places as well. But that glass, some of it is in fact even from single stream recycling operations, right?
Yeah, most of what we bring is single stream recycling. So we are dealing with MRFs and recycling centers from PA, New Jersey, Delaware, and even some glass from New York City comes down out of North Jersey. So we are
So that's really,
somewhat glass
yeah,
agnostic.
that's really interesting in that you're almost targeting the glass, in fact, that nobody else wants. In other words, it's not that you're taking away from, you know, a recycled glass bottle, let's say. You're actually using the glass that they couldn't use.
Correct. And I'll give you the extreme in Pennsylvania at our facility. We bring in the glass that nobody wants. We do the cleaning ourselves. The extreme opposite of that is in California, where we've partnered with Gallo Wines, and they have a bottle plant. They have their own recycling plant, and they are taking MRF glass, cleaning it themselves to go into their containers and color sort it. And when they do that, there's still a portion that gets screened out, which is their fines that they can't use, which would otherwise go to landfill. Well, they're going to convey them over to the building next to them, which is the building we're renting from them to make foam glass. So that's kind of one extreme to the other. And the fact that we can actually partner with a glass processor, container manufacturer, because of their waste stream that they can't use.
And it sounds like something we'd want to toast.
Yeah.
Indeed. So, with that, and if I'm correct, didn't you also mention that since you opened the facility in Pennsylvania, you equally have a facility in Florida? Is that right?
Yeah, so we started in Pennsylvania with one production line back in 2017. We now have 3 lines in Pennsylvania. We opened a facility in Central Florida a year and a half ago, which has 2 production lines, and about to open up the beginning of next year in California.
The product itself, talk about that a little more. You make, I think, is a closed cell product or open cell product. Can you tell us about that a little bit? What, when we hear, you know, about this, and then I think extending from that, we'll have a discussion on what other things the product can be used for.
Sure. So there's 2 basic classifications of foam glass: closed cell and open cell. Closed cell means all the bubbles are completely encapsulated in glass, so they don't absorb any water or moisture, and they act as very good insulators because of all that air that's trapped in there. The other version is open cell. Open cell, we use a different foaming agent, and that actually is used more for agricultural and growing media, where you can use it to retain moisture. So great for green roof soils and other kind of agricultural applications. On the closed cell, there's a dry process and a wet process. The dry process is what Aero focuses on, which is more for the infrastructure, heavy loading, roadways. The wet process is a little bit lighter, but a lot softer, not as strong for underneath roadways. So our equipment that we've brought in from Germany is designed that we can make all 3 of those products on our equipment. But 95% of what we do is the dry process closed cell for infrastructure. We do some open cell for some of the specialty applications.
Understood. And yet the lion's share of your business to date has been as an ultra lightweight aggregate, or at least in that type of end use.
Yeah, most of our work, the majority has been infrastructure related. We are doing quite a bit more now, kind of commercial and even residential construction, where the foam glass is used underneath the slab, first floor slab, as an insulating layer. So you can put it around the building envelope of a foundation, take load off of the foundation walls, create a capillary break, which is also a drainage aggregate, and then insulate that slab as well and get an R value out of the foam glass.
Well, that's just pretty amazing, to be honest. I mean, it's interesting that, you know, this has only taken fashion within the last decade or so, and even not that long. What do you see, I should say, specific products from the other plants in Florida and California, or is that also going to primarily be used for an ultra lightweight aggregate?
Yeah, so all the plants will focus on foam glass aggregates. Florida, we're doing a lot of dry process, but we'll also be running a lot of the open cell out of there. And when California is up and running, we'll be making both the closed and open cell out there.
Understood. Um, And you're primarily now using a soda lime container or bottle glass, whether it's bottles or say like pickle jars and the types of jars, we'd see in a grocery operation. You're not using, say, like a windshield glasses or borosilicate glasses, which would be like a laboratory glass. You're not using any of those. This is strictly for soda lime container type glass.
Yeah, so everything we're using is post-consumer. So this is coming off of that single stream container that goes to a MRF and gets separated out at the beginning. So, for example, Bob, we have a thermal reaction in our process. So if there's some borosilicate, like a Pyrex cup, that's not throwing our process off, but we wouldn't necessarily work with a Pyrex glass manufacturer to take their entire waste stream because we
Right.
want the glass reactant to the heat, which borosilicate glass is designed not to.
Understood. That makes sense. Makes a lot of sense. Well, what about uh let me see here. I was going to ask um in terms of your facility in near Philadelphia. If I recall correctly, you have 3 production lines there, right?
Yes.
So of those 3 production lines, to give, especially our recycling interested folks on the chat today, um, give some idea. I don't know, probably a 12-ounce glass returnable beer bottle is probably, I don't know, 3/4 of a pound, maybe. Like, give us some semblance of maybe how many bottle equivalents you're using, or how much weight of glass you're using at present, get to and what do you intend to do in your other locations as well?
Yeah, so with the 3 facilities in Pennsylvania, we're diverting the equivalent of about 45,000 tons. So the math on that is just over 200 million 12-ounce bottles being diverted from landfill. So last year, as a company, we crossed over the 500 million bottles diverted. But when the West Coast plant is up and running next year, we'll be on track to do over 500 million bottles diverted from landfill every year.
Wow,
So fairly significant. Yeah.
that's just amazing. And have you looked at all, like when we compare this? I know, for instance, you would share with me at one time, if I recall correctly, ultra lightweight aggregate, you're making this from glass, but it can be made from natural minerals too, as I recall, from shale. Is that right?
Yeah, there's a market for expanded shale. It's a very large market in the U.S. It's been around for a long time. Um, it's mined material that goes through a heating process that expands it to make it lightweight. But our advantage over expanded shale is really the fact that we're a third of the weight of the traditional lightweight, and we bring some more of the insulation properties along with it and the recycled content.
Well, which is where I really was going with the thing, in that, shale obviously is non-renewable, right? I mean, that's an aggregate from the earth, and similar process to heat it and to lightweight it, but yours is renewable in a sense of the fact that you're capturing, some of that energy back. So have you ever looked at like a greenhouse gas footprint or carbon footprint, say, of like your product versus a competing products like a shale product, or have you not?
We've looked at some of the stuff that's been done in Europe, and they have some comparisons, and we're in the process of doing it now. It's unfortunately it's a very long process, so
Oh
we're probably
yeah.
about halfway through. So we have a couple months to go, but beginning of next year we should have our that type of data.
Okay.
We've also gone to sorry, Bob. We've also gone to renewables too. So all of our new kilns are electric, so we can take advantage of renewable electricity. And we're also looking at RNG, renewable natural gas, for the existing gas lines to really take
I see.
advantage and reduce that carbon footprint.
Understood. So you are really trying to practice what you preach, so to speak, and drive that footprint down as far as you can get it as you continue to operate.
Yes,
Um,
yeah, it's a continual improvement process for us for sure.
and since we have a lot of folks from Pennsylvania on the line, so to speak, do we referenced earlier your sourcing of glass. my understanding is that it's not just glass from in and around Philadelphia. You work with other glass, purifiers and companies to get the glass, the portion that they don't want. So you're stretching into central Pennsylvania and other areas of Pennsylvania. We can't really or don't really want to discuss all of your customer lines. It wouldn't be fair, but to say that you are stretching into Pennsylvania is a fair statement.
For sure. And it's a, the math on the equation is, especially for people that are disposing of glass at, pick the $50 a ton disposal. It's really a matter of, what's their freight rates to get it to our facility to offset the cost of the freight and the tip fees at the landfills. And we have somebody at Aero that's their big part of their focus is balancing those costs for different sources of glass throughout PA. Locally, we've started working with some of the local communities to start to work on drop-off where they're maybe not currently recycling glass, but realize that we're relatively close. So we're doing some smaller programs to take some community glass also closer to the facility.
Understood. So you referenced early on when you first started talking, I think, that there's a number of quote unquote engineering standards and things that the product has to be able to do, has to be able to perform, has to be able to achieve when you test it physically or in the field or in the lab. So that says to me that there's a process of approval, for instance, with the State Department of Transportation or even the Federal Department of Transportation. And given that you're expanding into other states, that leads me to think that you're approved to use this for state highway reasons. Is that in fact the case? And if it is, where are you approved to do that?
Yeah, so it's the story behind this, Bob, is when we started, one of the references we make when you try to get a material approved at a state DOT level, they have standards for existing materials and you have to show that you match them or exceed them. Our challenge was with foam glass, there was no standard specification in any state in the US. So that makes the process a lot tougher, but we were pretty fortunate. We'd spent about 4 years prior to making foam glass doing a lot of this testing. When we showed up at DOTs, we were prepared. So within 6 months, we had 6 state DOTs in the Mid-Atlantic, and today we're at 23 state DOTs. And the only reason it's not more, we haven't gone to more states. We've basically been approved at any state that we've gone to get approval. And most of that is doing ASTM testing. The fun, difficult part is that each state has different requirements. So what we have to do for Pennsylvania can be completely different than what we had to do for New Jersey. And on the federal level, AASHTO, which is the American Association of State Transportation Officials, have some guides of what they want material to be, specifically around reinforced earth walls, mechanically stabilized earth walls, which are these ramp walls you see at most highways. So a lot of time spent in the early days being prepared to do that, and the first couple of years really spent going state to state specifically to get those state DOT approvals.
Well, on that note, we've mentioned, your expansion into places like California and Florida, and somewhat makes sense because we're talking regions of the country that, whether it's, like in Florida, I just picture swampland, so to speak, unstable soil areas. And you mentioned a project that's going on in Maine. Do you have any thoughts on the northeastern US? Have you looked at any, potential sightings up there?
Yeah, we have. We're still in the process. We were pretty far down the road on one particular site that didn't work out. So we are continuing to look at sites in the Northeast and 1 or 2 other locations across the country, and just a matter of spreading out the footprint. And back to the DOT part, one of the benefits is once you have over 20 state DOT approvals, we do see the process getting a little easier with other states. And for us, it's been a huge benefit that we have 23 state approvals, but we've been using all 23 states. So we have fairly decent sized projects as references in each of those states, not just that we were approved and have been used on multiple projects. So that's really helped the progress in some of the other states too, Bob.
Well, talking about projects, and I know some of us have heard the story of this. One of the projects that you were more recently involved with was this very large, unfortunate highway catastrophe in northeastern Philadelphia along Route I-95, a major corridor of the United States. My understanding is that unfortunately, due to a gasoline tanker fire underneath, an arch span of I-95, it heated that section of roadway and it collapsed, consequently shutting down a portion of the highway. But your aggregate was ready to step in and able to help with that. Can you explain that a little? I think that's just an interesting story, really.
Yeah, so like you said, it was a tragic accident. The truck driver lost his life, but he was carrying 8,500 gallons of gasoline and hit the abutment, and the truck exploded immediately. Pretty intense fire. Northbound 95 bridge deck collapsed. Southbound actually bowed, and then they realized it came back after the fire, but it was damaged too much, so they had to tear down the entire bridge, which left about a 130-foot gap between the two abutments. The bridge collapsed around 7:30. I got a phone call at 8:30. It was a Sunday morning from the head of PennDOT in District 6. So when you get a PennDOT call, 8:30 on a Sunday morning, something's wrong. And he explained to me what had happened, and they're considering foam glass as the fix. And then I got subsequent calls from the engineer and the contractor. And what they decided was the fastest way to fix I-95 was to close the off-ramp and put fill between the two abutments and pave it, 3 lanes in each direction. And that would be the fastest way to get it on traffic back running on 95. It's a major artery. 160,000 vehicles a day go over that section of 95. And, the stats where it counts for about $100 billion worth of commerce per year. So the Biden administration declared it the number one infrastructure project priority in the country. So the whole project was, how do we get it open fast and safely? So by putting fill between the two abutments, that was the decision. The problem was underneath the roadway where the ramp was, there was an 86-inch brick sewer that took out most of these sewer lines from Northeast Philadelphia, and a 36-inch water line. And they knew that
I just want to interrupt you there a minute, Archie.
Sure.
You just said a sewer line that was pretty high to the surface, so you need this ultra lightweight aggregate. You can't crush the sewer line. You can't put a regular soil or regular stone or something in there because it's going to crush these underground lines, right? But you just said a brick sewer. How old is a brick sewer? It's not even it's a pipe made of bricks.
It's bricks that are cemented together to make an arch to form these. These are 100-year-old sewers that are all over Philadelphia, and it's actually a combined sewer outlet, which some of the older cities like Philadelphia, New York, Chicago has, and they're in the process of replacing them. But these are sewer lines that run to a water treatment plant. There's a longer story, but it's not for the faint of heart of how they really work during storm events. So they know they can't put a lot of weight on it. The other part was when the tanker hit the abutment, a lot of the gasoline went down into the sewer and into the line and ignited. So they also didn't know how much damage had been done. So they realized they had to get fill on it, but 20 foot of fill would have been too much weight, where 20 feet of foam glass would have been 15% of what it would have been with regular fill. Wow. So as Aero, because of my background on the construction side, we said, look, we'll take the whole design, supply, and we'll put together the whole package for this reinforced embankment of foam glass with high strength geogrids. So we worked with the contractor, Buckley and Company, 24/7, supplying material, stockpiled it literally on I-95. They built it up, paved it, put up barriers, and it took them about 6 days to clean up the bridge and finish demolishing the southbound. But they actually built, paved, and put up the barrier in 6 days. So it was a 12-day repair, but only 6 of those were for that. And for us, what was kind of unique was everything that we talked about, the benefits of foam glass, ultra lightweight, goes in really fast, and goes in any weather. That all happened on the project. ultra lightweight they needed. It goes in about 4 to 5 times faster than traditional fill. And day one, torrential downpour as soon as they started constructing, and it didn't stop any progress at all. They were able to keep building during the torrential downpour. So it really checked a lot of the key boxes of why you would use foam glass aggregate.
So now, if I'm picturing this correctly, temporarily you can't get underneath that bridge span. That's all filled with aero aggregate holding up that road surface. And I would imagine as cars and traffic drive over that, all of that aggregate that's stacked up is going to vibrate. It might shift, it might move. It's going to get, much like if you do stand on a bridge and, a car goes over, you feel the vibration of the vehicle. Are you paying attention at all to, how that is holding up, or if it's moving, or
Yep.
are you,
So,
what's going on there?
so twofold. PennDOT had the contractor surveying the roadway and the barriers to see if they could see any movement. Aero, we went in, we set up LiDAR stations. So these are LiDAR cameras that, shoot thousands of rays of light and pick up a perfect surface. And we came back every 2 days and reshot it to see if we saw any movement. And basically, we're not seeing any movement of the wall or the roadways. So for us, it was a great field test where you get to actually see the surface of the wall because it was a temporary wrap face. They didn't want to go to the cost and time of pouring concrete on the sides. So it's just a geogrid wrap wall. So no movement. I mean, they're seeing thousandths of an inch, which is within the accuracy of the survey equipment. So
Wow.
we're not seeing any movement on the road surface or on the face of the wall.
And what do you attribute that to? In the construction or the material's ability to interlock with, like, piece by piece? What do you think the attributing factor is to that discovery?
A couple things. I mean, Buckley and Company did a great job installing the material. As much as they were pushed to go as fast as possible, they didn't cut any corners, so that was key. The other thing is the particles. When you feel a piece of foam glass, it has a very rough surface. So when you compact it, they do lock into each other. Even compared to traditional aggregates that are smooth, they want to slide a little bit. So this material, if you compact it and peel face away, the aggregate will stand vertical by itself because of that interlock between the particles. And that probably has a huge part to do with it, Bob. We also know from the Europeans, they've gone back and looked at bridge approaches that have been in with foam glass for 15 years and not seeing any noticeable movement whatsoever. So a little bit of that track record over in Europe has definitely helped us a lot too.
Well, one other thing, just to take a go back card really briefly, can you highlight for those on the call, just maybe paint a picture for us? This isn't just bringing in dump truck after dump truck and stacking up the ultra lightweight aggregate. You mentioned earlier, I think, was a geo wrapped wall, if I recall. Can you explain for everybody a little bit about what does that mean?
So when we place foam glass, we usually place it in a 2-foot lift, which makes it go in a lot faster as opposed to soil, which goes in an 8-inch lift. But because this was a reinforced wall, the reinforcement was every 18 inches. So we would bring in an 18-inch lift that we lay it down on a layer of high strength grid and then wrap it, then lay out the next layer, bring up an 18-inch lift, wrap that again. So we just continued that the whole way up. So you've got from the side view, it almost looks like stacked mattresses because of that reinforcement with the aggregate inside that. But one of the other keys specifically on this job was transportation, right? We can put the equivalent of 7 or 8 triaxial loads of fill in one walking floor truck that you might see at a recycling center. So we can get almost 100 cubic yards on one of those trucks, where a dump truck, traditional dump truck, is going to hold about 13. So on this particular job, 95 was closed. And one of the big issues was, how do we get the material to the working face? So when they blocked off the roads, we delivered about 90 truckloads of foam glass, which, had they used regular fill, would have been over 650 dump trucks. So there was a whole logistics section there, even outside of the carbon footprint of less trucks. There was just a pure logistics of 650 trucks down to 90. And we ran 4 trucks, just shuttling them back and forward until the wall was up to full height.
That's amazing. So So, again, coming back to an earlier question, as you said, you can reduce the footprint of the material as it's placed or used because of the light weighting of the product.
Correct. Less equipment to put it in, less lift. So about 4 to 5 times faster with less equipment. So it has during the installation, has a much lower carbon footprint also.
Right. And through this process of heating the glass and I'll say quasi melting it to make the aggregate, there's no contaminants introduced, seemingly. There's no heavy metals. I mean, really, you're starting with the content of the glass. I mean, it's always been, rumored in glass recycling. I've heard that when you get a ceramic paint, let's say, like a Corona bottle, that there might be metals mixed in with that paint in a place like Mexico, or a painted Coca-Cola bottle, for instance. And as you recycle that over and over, it becomes more concentrated in the glass mix. You've not seen any problems or issues like that at all with what you're making.
No, and we've been sampled quite a bit, especially with agencies like the New York, New Jersey Port Authority,
Right.
some of the other states. The Port Authority does testing on our material on every project they do, and we meet the residential clean fill standards on those projects. So we're not seeing any of that in our process, and we're taking the curbside cullet, which is fine. We use a recycled mineral as our foaming agent, and we use a little bit of a clay, a very tiny bit of a natural kaolin clay. So there's no other chemicals or metals introduced throughout the process.
Well, just yourself, Archie. What excites you about this? I mean, where do you? I mean, my gosh, it's just such a success story. But still, where do you want it to go? What's your next horizon with the thing?
Yeah, well, we do jokingly refer to this as our 10-year overnight success.
Right.
It was a lot of work. I mean, especially on the testing, because that's what's required on all these projects. So we did spend a couple years doing that. I think the last 2 years, when we started this, it was purely an engineered material for construction projects. But I definitely think the focus on sustainability has been a tailwind for us. We're doing a lot of resiliency projects where they have to raise the grade around areas that flood, which creates surcharge. So between resiliency and sustainability, they've been two tailwinds. But I think the most exciting part for me, Bob, is what we've seen over the last 2 years is the awareness and the repeat use of the material. So it's one thing to get a state DOT job, but when they come back and start specifying it all more, for me, that's the real test that they're comfortable with it. So I think it's continued to expand our footprint. We do a lot of R&D still. Teresa Laux, who's our chief technical officer, she runs that program. So we've got some IP that's been developed on some specialty applications. And what's really been neat, is exciting, is the new applications. We're constantly learning about new applications for foam glass, even outside the infrastructure market. So I think the growth, the footprint, and some of these new applications are a really exciting part of what's going on at Aero.
Oh, no doubt. And you're right. I mean, you would seem to think the more demonstration projects that are successful that you get out there, you know, the more popular it's just simply going to become. Um, yeah, do you feel you're at your capacity for glass at any of these locations, and certainly Pennsylvania? Are you still eager to source as much material as you can get?
Yeah, I think as you guys and most of the people on the call will know, there's a lot of glass out there. I think our focus is on getting the best glass, and the best glass for us is the least amount of contaminants. We have our own cleaning system, right? So we can take glass with paper and plastics, and our mill that mills it into a powder is
Yeah.
specially designed. I mean, specifically designed for glass, and does the final cleaning if any paper or plastic gets through our cleaning system. However, the cleaner that source is what we're more interested in, because it just makes the cleaning process that much more efficient, so better throughput. So we are always keeping our eyes open for sources of glass.
Well, just to kind of put it in perspective of many on the call, and I don't know if you have this at, value to mind, but, I've been told at one point that, the fines that you see in single stream glass can be those fines can be anywhere from, I'm going to say 30 to 60%, like shredded paper label, or, bottle adhesive, like little balls of bottle adhesive, or in other words, 30 to 60% of anything but the glass that you want. Is do you find that to be the case? Do you monitor that at all? Is that in
We
fact an accurate span?
Yeah, so we see it quite the range, right? We've seen it even higher than that, and we can run that through our process. It's not fun, right? Because it
Right.
doesn't, and the more paper with the moisture, it actually almost acts like a paper mache and starts to bind up on the glass, which makes it even more difficult. But we have seen it that high. So we work with a lot of the MRFs and the people who are supplying us glass to try and have a band of what we expect to see from them, and we'll do LOI testing on the loads that come in
Right.
to make sure it stays within that band.
And LOI, for those that
Oh,
could
sorry.
benefit from
Yeah.
a transfer of knowledge there.
Yeah. So LOI is loss on ignition, and that's where you heat up the glass that comes in, and anything that has organics, which is the paper and the plastic, burns away. So you measure the weight before and the weight after, and the only thing left is the non-organic, which is the glass. And that percentage tells us how much organics were in there, which is what we don't want in the product. And it's one of the things that help us also, Bob, with the manufacturing process and the final aggregate, because the final aggregate is 100% glass and there's no organics in it. So that really helps on the durability long term. And the fact that it's closed cell, doesn't absorb any moisture, so no issues with freeze thaw also in the aggregate.
But I think it's important to point out too that, and as you just explained, I threw out a number of 30 to 60%. You said sometimes higher. Let's just go with a number of 50%. You can have a situation where half or more than half of a truckload of, and I'll focus on single stream glass fines, is in fact not glass. It's material that you have to filter out, you have to separate out and get rid of. That's
Right.
unusable. That's landfill material, or just unusable non-glass material. And I think it's important to point that out, because you have a hard cost to clean that up. And as a result, that factors into needing some sort of tip fee, I assume.
Exactly, because it's we're bringing in a volume or a weight, we're putting it through the process. The more higher that percentage is, the more time it takes through the cleaning process, which lowers efficiency. And then the byproduct, you're right, goes into a roll-off container that we then have to pay to dispose of. So the economic shift the wrong way for us because of the cost of disposal of all that paper and plastic that comes off.
Right, right. And I assume, is it fair to say that the smaller the gradation, or the smaller each particle of glass that you get in, is it more challenging to get out the portion that you want to get out? Or, in other words, is it more mixed up, so to speak, or
Yeah,
you know?
I think the smaller the glass fines with the heavier organic content is probably the most difficult. And you explained it pretty well, because you'll get smaller pieces of glass getting bound up in that paper where the larger pieces won't. So a little easier to separate in our cleaning system. So that's why we said, like, we can manage a lot of these, but we definitely have a preference. We find that kind of middle of the road where that percentage is down, that goes through our cleaning process, and then it kind of reduces the volume of disposal we have.
And that's also something, I guess, controlled in your facility, where you can maybe accept some really, really cruddy stuff if somebody's willing to provide you a tip fee to clean that cruddy stuff. But then you've got some stuff that's maybe really, really clean, and you can kind of blend it together and, balance out how dirty it goes into your process.
Yeah, we've been able to do that. The old, which I shouldn't say on the call, but the old solution to pollution is dilution, right?
Right.
So
Right.
if we can mix in some clean color with some stuff that's relatively dirty, that'll bring the overall average down and does run through our process a lot better.
Of course, various treatment processes where you have a high strength waste, the key is to get the concentration to an equilibrium or to a flat line so that you don't have the peaks and the valleys. Somebody had expressed it to me once as to administratively homogenize your feedstock versus solution to pollution and dilution. But at the end of the day, it can be a balancing act with what you're willing to accept or not accept.
Yeah.
And it sounds to me too like the leftover bottle residues or stormwater and that just dampness and the wetness is a large factor in how it clumps or how it goes into your cleaning process too.
Correct. Yep. It does. And we have, part of our process is a dryer before it goes into the milling to pull any of that residual moisture out of there. So the glass is dry before we start to mill it.
So so Archie, what else have we not covered here? What do we need to talk about? What when you step away, yourself, we say we talk a little personal too. When you step away from making aggregate, what does Archie do with his weekend?
Uh, yeah. So if my spare time is probably spent with my family, mostly, I've got two children. My son Archie's a civil engineer working for a firm in Philadelphia. So it's kind of been fun running into him work wise on certain projects, which has already happened. I got a daughter that's up in school. Try to go out a little bit, do a little bit of the Jersey Shore, and try to get downtown Philadelphia nights out most of the time. Yeah, that's probably nothing too exciting, Bob.
Well,
But
the reason why I bring it up too is, there's nothing wrong with being a little lighthearted today too, and we want to be able to have these types of sessions so that if you're at a conference or you're delivering a session or one of our attendees today bumps into you, we all need to recognize that at the end of the day, we're all approachable people, right? And whether it's the operator, the broom pusher, or the owner, and we certainly appreciate you taking time with us today. We've had a few questions that I've worked to try and answer along the way. If anybody has any questions, please type those into our Q&A feature here, and we'll be sure that we capture any questions that you may have. Archie, if someone's on the call today and they have, other than getting in touch certainly with the Recycling Market Center, if they'd like to speak with somebody at AeroAggregates about their glass, so to speak, is there somebody you have on your team that they should reach out to?
yeah, so Larry Bamford's our president COO. But for this group, if you want to send me an email, I can make sure it gets to the right person, and it's just Archie, ARCHIE, and then it's one word, Aero, AERO, aggregates.com. And Bob, I think the other thing, what's been interesting on this repair of 95, you said it, we got a ton of publicity over this. But what's been really interesting is the amount of outreach we've gotten from DOTs across the country to come in and present to them. So we're out in Pittsburgh last week. We're in Hershey tomorrow, or Thursday and Friday, Connecticut, Virginia. So we've been doing a lot of presentations, kind of what is foam glass and the part we played in the I-95 repair. So we are doing a bit of a tour right now all over the area, presenting that if anyone's interested. It gives a little bit more deep dive into the details, mainly because the 95 was such a high profile project.
Well, talking about deep dive, there was another question recently came up. Could you please re-explain each one of these pieces, which you can see at your website, at the AeroAggregates website, it's some really good photography there. But each one of these individual pieces, as I've explained, to me, when I hold it, it feels like a pumice, or it feels like almost like the roughness of a fingernail file, or to me, it also looks like, and weight wise feels like, the lava rock that you would put in a gas grill. Okay. Just physically, that's what it seems like to me. And of course, igneous rock is, naturally occurring volcanic rock, is a type of foam glass, but naturally occurring. Regardless, could you re-explain the difference between an open cell, I'll say nugget, which of course I know you love that
Don't
word.
say nuggets, yeah.
I figured I'd slip that one in there
Pet,
on
pet peeve.
uh compliments of the popular press, but an open cell piece of aggregate versus a closed cell, and the difference there. I know you said that the foaming agent that foams the softened or melted glass, it's a different foaming agent will cause it to be closed cell or open cell. But can you explain the physical difference?
Yeah, so what happens is when we make closed cell, the foaming agent is a mineral, but the way it reacts very slowly, very slowly. So as the powder goes in with the foaming agent into the heating process, the little pieces of glass powder start to sinter together to create a closure of a bubble. And as that mineral starts to create the foaming process, the bubble starts very, very slowly, so it can keep the bubble intact, which makes it closed cell and no moisture can get in. When we make open cell, we use another mineral which reacts much faster. And that fast reaction creates cracks in the bubbles, and all the bubbles get interconnected. So if you take a piece of open cell and put it on a drop of water, you can actually see the open cell, because of the capillary attraction of those fine little pores, suck the moisture into the open cell. So that's the difference. When you look at the two aggregates side by side, little difficult to tell the difference between the two looking at them, other than the closed cell's a gray color, where the open cell's an off-white color. And it's not until you actually put them in water. And if you put both in water, the closed cell will float on the surface. The open cell will float for a few minutes as it sucks up the water and then sink to the bottom. So difficult to describe it, other than the outside surface. And I didn't say this, Bob, in the beginning, but when this powder goes through the heating process, it bakes into a cake, and it's a solid cake of foam glass. So when it comes out of the kiln, it's solid, but it goes through a rapid temperature drop, which puts thermal stress in the cake and causes it to crack into inch and a half aggregate, all naturally. We don't do any crushing or screening at Aero, so that all happens naturally. So when you look at the surface, you get this very rough surface, like you said, it almost looks like pumice, but that's just the broken bubbles on the outside. The bubbles behind that are still closed cell bubbles. And you're right, somewhat similar to like a pumice or a volcanic rock, but about half the weight of even pumice. And pumice in the volcanic rock, a lot of those pores, it's more like an open cell than a closed cell.
And that's where you had said earlier that open cell rock, if you will, or aggregate, as that draws the water in, it's so lightweight, but that it'll hold that water in those tubule or interconnected bubble spaces. And that's what makes it good, for instance, as a hydroponic growing media or a green roof aggregate to grow, like low height, plants as you would have on a green roof. This is what allows that to take place, because the root systems of those plants are going after the water that's located in those open spaces, if you will.
Right. And that specific material at Aero, we market that as growstone. So
Okay.
it's exactly that. You till it into the soil, and what it does is it not only retains the moisture in the aggregate, it retains oxygen there too. So the
True.
best way to get a big yield is that mixture of moisture and oxygen, so you get better yields. But the other part of that is it's granular, so it still allows drainage. But as the soil around it dries, the soil suction is stronger than the aggregate's ability to retain the moisture. So over time, it releases that moisture and any fertilizer you have in the aggregate back out into the soil. So great for kind of green roof soils or other horticultural applications.
So another observant question came in, which is that if an open cell can retain some water, but yet closed cell does not, which is better in a resilience project that involves like intermittent flooding?
Right. So that it is a great question. We get it a lot. We use all closed cell to keep it lightweight on these resiliency projects. And the question we get is, how can you use a aggregate that can float in a resiliency project. And we do it all the time. We have a design manual that shows that if you're going to bring up 3 or 4 feet of foam glass, how much cover soil you need to keep it from being buoyant. So that's mainly what we use on these resiliency projects. And the idea there is you're creating lightweight that doesn't absorb any water, because if it absorbed water, it would increase in weight.
Right.
And that would create more of a surcharge. But the other benefit we show is that when it's compacted, it still has 40% void space. So when that storm surge flood comes, the embankment of foam glass has the ability to absorb 40% of its volume and moisture and still promote infiltration.
That's with the closed cell.
Closed cell, correct.
Right. So even though you don't have that inside spaces, if you will, like you do in the open cell, you still have enough divots, much like a golf ball, divots and dimples, and between the individual pieces.
Yeah, the void space of 40% is between the actual aggregates themselves. So the aggregate's not absorbing the water, but the voids between the aggregates is about 40%. So that gives you a pretty high capacity to pull that moisture in and, like I said, store it, and then even promote infiltration too.
I understand. Thank you for explaining that.
The open cell has some potential applications that we're just testing now for internal curing, where when you have a high strength concrete, it creates a lot of heat. You can soak the open cell, put it in the concrete, and as the heat of the concrete from curing comes in, the moisture comes out of the foam glass and slows that dehydration process, which gives you higher strength concretes. And you see a lot of these applications for bridge decks, mostly DOT type work.
Well, I know that's one area that you've worked on with the Recycling Market Center, where we've been able to partner with Penn State and do some early stage commercialization research related to the use of ultra lightweight aggregates in things like precast products and masonry block and so forth. And we'll continue to see, what evolves with that, along with many other things that we've worked on together now over almost 9-year period we've known each other. So in any event, I think we have another question may have popped in here. Question came up. What is there a way to compare, or is there a comparison between an ultra lightweight closed or open cell aggregate and perlite?
So interesting question. So we are looking at that same as the moisture retention, whether it's soils or for internal curing concrete. With that, we would look to size our material. So we'd have to put it through a crushing and screening operation. And so almost the opposite of perlite, where they mine perlite and then heat it up to expand it. We would be heating up, expanding our foam glass, and then crushing it down to get to perlite size samples. But it would act the same way. It's a lightweight bulking material that actually would also have some moisture storage. And the silica in the soil also helps the root structures. You get a more robust plant when you have free silica in the soil. So there's some benefits there.
Well, and here again, it's a situation too where, you're located, your ingredient, the glass, recycled glass, is also usually in an area where you can use your product. Whereas, the shale, we have to go get the shale from a quarry and then bring it to its point of use. Same is true of the perlite. We have to mine that and bring it to its point of use, where, from a footprinting perspective, you're already at the location of use potentially.
Yeah, and even more so with perlite, right? Because most of that is all mined in the West Coast, right? So there's no mines in the East Coast. And we kind of, jokingly refer to our material as we could use it as an urban mine, right? Our facility is 6 miles from downtown Philadelphia, so we don't need a mining permit.
Well, I'm sure you need permits for many other things, though.
Yeah, there's others, but
yeah, there's others in line with that. Another question, somebody, I think, rather astute observation, is your, because it's made from glass, is it fire resistant?
Yeah, so it is. We put it through a very high temperature kiln, but we've done some work on rooftops of casinos in Las Vegas, and even though we knew it was fireproof, we still had to go through the standard ASTM test, which we did at PSI out in York. And basically it gets a A1 rating, no fire and no smoke. And that's their biggest concern around building envelopes, that you're not going to create any smoke with your insulating material. So, and even on the DOTs, we show engineers that if you loaded the foam glass with gasoline, put a match to it, lit it all on fire, the gasoline would eventually burn off and there'd be no harm or detriment to the foam glass at all.
Which is one of the obvious advantages over using polystyrene for that purpose. So,
Right.
so
Absolutely.
that's interesting. It doesn't melt. It just, the material is not impacted by the thermal stress of the fire.
No, you would have to get, and with gasoline poured on it, lit up, you're not going to see that. You'd have to be up over 1,500 degrees to start to have any effect on it.
Okay. Well, again, all very, very interesting topics for today. Appreciate some insights into you, Archie Filshill, as well as AeroAggregates. And you had thrown out earlier your email address, archie@aeroaggregates.com. If anybody would need to follow up for some reason, and certainly can follow up with the Recycling Market Center as well. I'm going to look after about an hour here. I'm going to look to draw a close to our session for today. We again appreciate all of our listeners, all of those that have attended. Certainly here within the next 2 weeks will be our Thanksgiving holiday. So we wish everyone a happy Thanksgiving and a wonderful fall season as we roll into the rest of our year. And Archie, yes.
Yeah, just one. I do want to make it a point. I wanted to say this before we finished up, that as a relatively new company, we really do appreciate the support of the Recycling Market Center from day one. Not only with some of our initial testing and going through the DEPs and the DOTs, but a lot of this recent partnerships with the universities on application development. It's been a tremendous help for us, and sincerely appreciate that.
Well, thank you, Archie. I commercial that I didn't pay for, so I appreciate it. But no, we certainly enjoy being involved with AeroAggregates as well. And we'll have a few more developments in that regard upcoming very shortly. So with that, I'm going to sign off for today. Again, thank everyone for your attendance. Thank you for your attention. If you have any follow-up, please follow up with the Recycling Market Center or AeroAggregates, and have a good day.
Thanks.
Thank you, Archie.